My name is Tzu Mainn Chen. I'm a software engineer at Red Hat, and today I'm going to talk about ESI. So what is ESI, or Elastic Secure Infrastructure? And there's a variety of ways you can think about it. The principal one is it's a bare metal cloud that's designed to be used by multiple tenants. So in this model, in the single ESI instance, you might have a bare metal cloud where all the hardware is provided by one organization, or you might have multiple organizations pulling their hardware together into a single ESI instance. Regardless, the base principles are the same. Owners have exclusive use of their hardware, but they can also offer up their hardware for lessees to use. Lessees can see these offers, they can claim these offers, and they can claim these nodes, and once they have access to the nodes, they can provision their own bare metal clusters on their private networks, and that's the secure part of Elastic Secure Infrastructure. When the lease is up, the lessee loses access to the node is cleaned, and the node is just returned to the offer pool. The other way I like to think of ESI is really just OpenStack. So it's Ironic, the bare metal service, Neutron, the networking service, Keystone, identity, Glance, image. And yeah, we get the benefit of the enormous OpenStack ecosystem, and a lot of the requirements we have were just fulfilled just by virtue of being part of OpenStack. So it's been really great for us. So you can think of ESI really as just as a specific configuration of existing OpenStack services. That being said, we have developed a few tools on top of OpenStack to help us out. The principal one being a leasing service, and what that lets us do is just track leases and make it really convenient for us to see like which nodes are being used by which projects, and look at lease history and things like that. The other extension we've created is the extension to the CLI. So what we discovered is that with the base OpenStack CLI, there's going to be a lot of operations you want to do, like attaching a node to a network. And using the base OpenStack CLI, you'll need like 5 to 6 CLI commands. And it can be a little bit complicated and very intimidating if you never used OpenStack before. So we've extended the CLI for ESI, and so commands like that now just take a single command, and it's been really great for our users. So who's using ESI? And this is something that we've worked on a lot in the past year or so, setting up a production MOC ESI instance, and really encouraging users to use ESI and getting their feedback and understanding how we can make ESI better. So the current production MOC ESI users, they kind of fall in one of two categories. The one is grad students from BU and Northeastern, and a lot of these users have been migrated from Hill BMI, which is the old bare metal allocation and provisioning system. So the typical workflow there is that a grad student project comes to us, they request some nodes, and we allocate them some nodes. Then they'll create their private network resources using the OpenStack CLI, and then they'll provision their nodes using Metalsmith, which is an upstream OpenStack bare metal provisioning library. Once they're done, they'll network their nodes using our ESI CLI, and then they'll basically be done with ESI. They'll have their own private bare metal cluster, and then they'll do things of which I'm not fully cognizant, but there's things like distributed storage research and operating system experiments and unit kernel experiments and stuff like that. Again, I don't really know the full details, and I don't really need to. I just need to know they're using ESI and they've used it to set up their environment successfully, which is really great. Our class of user right now is OKD, and OKD is an upstream version of OpenShift. Initially, when they came to us, we allocated them 12 nodes, which they use in 2 different OKD clusters. Each cluster has 1 bastion host, 3 masters, and 2 workers. One cluster is used as a build cluster, and so they stood that up a while ago, and it's just been running ever since. The other one is a CI cluster, so that one gets torn down and rebuilt nightly as part of their CI. We've recently given them access to 30 additional nodes, which they can claim elastically, and their plan is to claim them and use them as part of their CI pooling service. And what I understand their CI pooling service is they have this service which consists of a variety of bare metal nodes, some of which they own and are local to them, some of which they've acquired from other sources, and now they have access to our ESI nodes as well to expand their CI capabilities, and that's really cool. So the way they use ESI is they've there's a developer on your staff that's really experienced with OpenStack, and he created the custom scripts that use a combination of the OpenStack SDK and the ESI CLI commands to configure and deploy their nodes. There's also a couple of projects and ideas that I've mentioned to us that have been driving our development. One is Cloud Lab, which really wants to lean into the elasticity of ESI, being able to claim nodes and put them into their test bed and things like that. I'm not going to go into too much detail there because the manual is going to talk about that a little bit later. And then you see a variety of other projects here. And one thing that they all kind of want to do is they want to be able to quickly stand up small test OpenShift clusters in order to do measurements and experiments and things like that without disturbing their production OpenShift instance. So those are just things that have been ideas that have been brought forth to us that have been driving our development recently. So some observations after this year of usage. So for a lot of users, after some initial questions on how did we use ESI, what do we have to do, we don't actually get a lot of feedback. And our documentation is pretty comprehensive, and we do constantly update it based on feedback. But really what seems to be happening is that many users, they just simply provision their bare metal clusters, and then they never touch an OpenStack or ESI command ever again. And they're perfectly happy, and that's fine. Other users have a lot of OpenStack experience. We give them credentials to access ESI, and they're like, okay, yeah, this is just OpenStack. Okay, I know what to do now. And they create their scripts, and they do their things. And again, they don't really need much help from us. And again, that's totally fine. It's totally great. But what this really means is that it's kind of difficult to identify places where we can improve the user experience. But we still try. So how are we trying to make it easier? The first one is with something called the ESI cluster CLI. And the idea here is that, let's say there's a pretty typical, you want to deploy a pretty typical bare metal cluster, 3 nodes on your private network, and you want to attach an external floating IP to one node so you have external access. If you use OpenStack CLI commands, ESI CLI commands, you need between 5 to 10 commands to do all of this. And if you've never really worked with OpenStack before, again, it's going to be a little scary, a little intimidating, and you'll have lots of questions. The ESI cluster CLI lets you provision that exact bare metal cluster with a single command. OpenStack ESI cluster orchestrate, and then you pass in that sort of configuration file up there. So not only does this make it much, much, much simpler for users to provision their ESI clusters, you just need this configuration file. And you can also share this configuration file with others. So if there's a pretty typical configuration that you're using and other people might want to use, you can just download it and then just substitute your own parameters for your own nodes, your own private networks, and you'll be done. You can just run this command. So that's the ESI cluster CLI. We have a couple of additional commands besides orchestration. There's a list command. So if you want to deploy multiple bare metal clusters, you can use this list command, see your different clusters, see which nodes you're using, and just kind of keep track of where everything is. And then there's an undeploy command. So if you're done with the cluster, we'll clean the nodes. And then more importantly, we'll also remove any associated OpenStack resources like ports or floating IPs. And what we discovered is that if we don't do this, then what tends to happen is you'll start running into the boundaries of your OpenStack quota. So this was a great first step. And then we asked ourselves, can we do something a little bit more? So what we did next is we explored, can we do the same thing with OpenShift? Can we create orchestration commands to deploy OpenShift on ESI nodes? The answer is actually, it's not that bad. It's pretty straightforward. You just need to use a combination of OpenStack SD commands and OpenShift assisted installer API calls. And you can just pass in configuration file, like the one over there, run OpenStack ESI OpenShift orchestrate, and you will get the OpenShift cluster at the end of it. So that really simplifies the process for a lot of users. We've also added some tools for ESI operators as well. There's the typical reporting tools where if you want to know the status of every node, if you want to know how many nodes are assigned to which projects, you can run a single command and you can get that. The other big thing is leasing history. What leases are active right now? What leases were active this week? What leases were active in the past month or the past year? All these commands, you just run. We have CLI commands to generate these reports in a variety of formats. And I believe that right now we have daily, weekly, monthly jobs to kind of all generate these reports for people to see. The other thing we've been looking into is events and notifications. So now, if certain ESI actions will generate an event, like when a lease is created, or when a lease begins, or when a lease expires, we create an event, and then these events can be monitored for various purposes. So for example, we're starting to implement email notification systems so that users have a daily reminder of what nodes they actually have access to, and also reminders when their leases are about to expire, so they know they need to save their information or do other things with their data. So our tentative short-term plans, we want to continue to make it easy for users to script and provision and manage their bare metal clusters. And one way we could do this is to just keep extending the CLI. Do things to make sure that our CLI commands can handle more configurations, integration with more applications, stuff like that. I kind of think that is the wrong path to go down, because there's just too many different ways people will want to configure their bare metal clusters, and there's too many applications that they'll want to and services they'll want to integrate with. So instead, we're currently focusing on an ESI SDK, and what that will do is it will expose the building block pieces that users can use to create their own scripts. So when the ESI SDK is done, we'll update our CLI to use this SDK. And then when users start using ESI, they can either use our cluster CLI, or if they want something more complex, they can look at our code and figure out, oh, we can use this SDK to do our own thing and then go their own way. Another thing we've been thinking about, and this is actually pretty minor, is the automatic creation of network resources. And that's just when a new user comes into ESI, they always have to create their network resources, and it's a little bit of a pain. It's not a big deal. And really the only reason I mentioned this is because I brought this up a while ago, and Christy very kindly said, oh, ColdFront actually already does this. Maybe you can use their code. I looked at the ColdFront code, and it's like, yeah, this kind of works. And the reason this works isn't because ColdFront already magically has some ESI integration. It's because ESI really just is OpenStack. So ColdFront works with OpenStack, and so a lot of the tools that people may have that work with OpenStack will just automatically work with ESI. Long-term areas of interest. The first one is really leaning into this idea of having a hardware bazaar. And what I mean by this is that right now, when users claim offers in the MOC ESI, let's say the node is available for a month, and they only need to use it for like a day or a week. They really have no incentive to claim it only for the day and the week. They'll claim it for the entire month, even though they might not need it for that entire time. And so we want to create those incentives for users to think of ESI a little more elastically, to grab the nodes only when they need it, to return them when they don't, and then make those nodes available for others to use. There's a question of security hardening. Right now, the MOC ESI works on a trusted user model where, when you receive a node, you can be assured it's been cleaned, but you can't always be assured that a previous user might not have done some low-level alterations to the node, like changes to the BIOS or things like that. So we have some ideas of how to prevent that, and we've also played with tools like Keylime, which is a node attestation service in the past. Integrating with Keylime, we've discovered, is really easy. You just have to set up your Keylime attestation server on a node, create a private security network, and then when you want to test a node, you just have to attach that node to the security network. That being said, not every single node in the MOC has the requisite TPM chips, so there may be other solutions and other ideas we'll have to look into. There's always been the question of a GUI, which is something that we've long avoided. That's something that's just not strictly necessary. The CLI is pretty comprehensive, and we've had a lot of success in just using that. But I know there may come a time when people ask for visualizations or just want an interface that's more point and click, and that's something that we definitely consider doing. And finally, I don't know, there's ESI is like a really broad platform, and there's a lot of ways you can interact with it. And so if people have their own ideas, their own interests, I'd be delighted to hear about them. Just come find me, talk to me, and I'd love to hear about it. Thank you. Any questions?
Hi, everyone. My name is Naved, and I'm a software engineer at the MOC Alliance. I've been with the MOC, I joined them since 2017, so I've been here for a while now. But I'm here to give you a brief update about the hardware that we have at the MOC Alliance. So we have like over 1,000 servers tracked at the MGHPCC that are available for people to use. Let's just briefly describe what the servers are. We have 140 Dell FC830 servers, and each of these servers have 4 CPUs, so they make great servers for high-density compute needs. On top of that, we have 440 FC430s, and these are great for any general-purpose use, and they make the bulk of our servers. Then we also have FC630s that like sit in the middle of these two types of machines. The FC830s and 630s have dual 25 gig NICs, while the FC430s have dual 10 gig NICs. And in addition to that, we have a bunch of random Dell PowerEdge servers of various generations that we have had for a while now. And as you heard, we recently got some Lenovo servers. Each server has like 4 GPUs that gives us 64 GPUs. And it looks like we'll get more H100 servers next. And then to connect all of these servers right now, we are using the Dell Z9100 switches. These are 100 gig switches, so that is great. Like, we only need 2 per rack, and we can like break out to connect all of those servers. And like half of these servers have like a terabyte SSDs to boot with, so which is great for fast provisioning and booting. Okay, let me tell you how some of these servers are allocated. So we have like 113 servers are in, we have 100 servers in the Open Cloud testbed, and then another 104 servers in the NERC OpenShift cluster. And currently, these are all statically allocated because we didn't have ESI stood up. So eventually, all of this hardware and any future additions will be only available via ESI. So yeah, for now, we then set up ESI, and I'll tell you what's in ESI. Okay, so we set up ESI, which is basically an OpenStack deployment, as Min described, which is running on 3 OpenStack controllers. That's plenty to handle most of this hardware. And in our deployment, we have 317 servers across 6 racks. And these are a variety of Dell servers of the kinds I described earlier. And ESI is currently managing 14 of those switches. And we are in the process of upgrading our controllers to even more powerful servers just so that we can add more hardware. And the hardware that we plan to add to ESI is another 300 Dell servers. They're basically ready to be added and deployed. And all of this, again, will only be available via ESI's leasing mechanism, just so that we can easily track who has what, and people will not message me on Slack anymore. And that will bring our elastic capacity to 600 servers. Let's talk about storage a bit. So a lot of people who are using this ESI nodes are PhD students and researchers who just want some storage available. And for that, we have a research Ceph cluster, which provides them with a petabyte of storage across 120 USDs. Which would be sufficient, I hope. And for people who want to run like production services on these ESI nodes, they can make use of NESI. Just like how we are using NESI for our NERC OpenShift cluster, people can then take these ESI nodes, run whatever service they want, and get storage from NESI, and that would be more highly reliable Ceph storage from that. So I did forget to change my slides. But yeah, that's pretty much it. Cool.
Hi, so my name's Hakan. I'm an engineer on the MOC Alliance. I've been here for about 2.5 years full-time, and most of my responsibilities lie with the network behind all of this stuff, so I'm going to be talking about some of the problems and some of the solutions we've developed for that today. So there's kind of a few problems that we have here. So ESI is really good at dynamic switch port configuration, and it's one of the major reasons why it's so good for dynamic allocation of nodes, because it goes in, it changes the switch port, and sets it to whatever VLANs it needs to be automatically. The other side of that is static configuration. Historically, we haven't really had a system that will allocate, will set switch configuration statically to correspond with ESI's dynamic configuration. So these are things like uplink port configurations and VLAN names and descriptions and things like that are all static configurations that we historically have had to set manually. So another thing is that our network configuration has not been exposed publicly. So, and Christy mentioned this, that our mission is always to make everything reproducible, everything as open source as possible and reproducible. And networking has always been a pretty major missing piece of that. And I think there's not a lot of people that are exposing their network configuration. But it's important when you're setting up clusters like this that if you want to reproduce it, you want to see how the networking is set up on a switch port level. And also network engineers from other organizations may want visibility into how our network is connected, especially the open cloud network, because it connects to so many different places. So networks also often have a lot of different vendors and operating systems for switches, especially one that grows at the rate we are. So at the moment, there's not really a way to generically define a switch configuration for different operating systems. Another problem is collaboration. So collaboration is hard if we're just manually configuring switches, because there's no version control, there's no central configuration to view configuration, which is not really how we do everything else at the MOC. So the organization of it is also a pretty big challenge, because there's a lot of different projects and a lot of different connections. Our open cloud network connects to endpoints at UMass and Harvard and BU, and also for NERC and OCT as clusters, and because of that, there's a ton of VLANs to keep track of. And one of the last problems here is that end users don't have a single place to view node details and network topology relating to nodes. So that's like if you had an application where you wanted to cluster a bunch of nodes together, but your application is concerned about latency or bandwidth, you want to know how those nodes are connected to each other. So that might be one node in one rack and one in another, and it goes through two or three switches to get there. Maybe you don't want that. Maybe you want it in the same rack so that you minimize latency and it's only going through one switch. So that topology is not something that's currently exposed through ESI. We do expose node details, so you can go in through the OpenStack CLI and get that information, but the topology itself is not exposed. So we're going to be using Ansible and some things that we developed on top of that to solve some of these problems. So Ansible is already a proven automation software, and it's got heavy backing from the community, and that's one of the reasons we're making use of it here. So things like Dell OS 9 is the operating system that we run on our switches. So Ansible has a module for that already, where we can issue commands through the OS 9 module, and we don't have to worry about that piece of the puzzle. So this solution involves storing switch configurations as YAML manifests in a public repository. So this is very similar to how, for example, Kubernetes manifests are handled in other areas in NERC and other projects, where they are manifests that are stored in a public repository, and then there's some continuous deployment solution on top of that. So we're trying to kind of replicate this in the same way for network configurations. So when we have them in a public repository, changes then become pull requests, and now the collaboration piece becomes a lot easier. And it also allows us to expose those configurations publicly, which is one of the major goals for this. So on top of, we can't just run this through Ansible. I mean, to fulfill some of the problems that I talked about, we have to develop a switch driver, basically, that's written in Python. And it allows us to take generic switch manifests and convert them into commands that are then executed on switches to deploy that configuration. So that's what I'll be talking about today. So the initial work on this is already being completed. The Open Cloud Network is currently being managed by this solution. Around about 600 plus servers and 36 network switches are currently being managed by this management solution for the network. It's managing ESI, OCT, portions of NERC, and portions of Fabric, and connections to Harvard, UMass, BU, and Northeastern are all handled through this. And the GitHub repository link is there if you'd like to visit our Ansible site deployment and see how it works. So how does it work? So we'll talk about VLANs first. So the way VLANs are defined is they go into a YAML file, and you define, like it appears on the right there, for each VLAN ID, a name and a description. And you can also specify whether it's managed or not, which I'll talk about later. So this is read by Ansible as a group variable. So that allows us to say this set of switches should have these VLANs. So maybe the switches in OCT don't need the NERC VLANs and stuff like that. So that allows us to kind of separate the layer 2 environments in the network. So in a similar vein, for port definitions, it's also defined in a YAML manifest as a host variable this time through Ansible. So now we're defining each interface on the switch and defining a whole bunch of fields that I won't list all of them, but there's a bunch available. So the goal here are that these manifests are generic. So we don't want to have a Dell OS 9 specific manifest. We want a manifest that is generic in nature for all the fields. So the only thing that's specific about these are the names of the interfaces themselves. So if you look at the example on the right here, like 100 gig port 130, that's what it's named on the switch. So the idea is you can then take this, and just by changing the interface labels for whatever the switch calls it, you can deploy it on some other switch of a completely different vendor if that switch needed to be swapped or something like that. So it keeps it generic. It also simplifies the understanding of the network a lot. You don't need to be versed in the specific switch operating system to be able to look at these files and understand how the network works. So there's a lot of parameters that are supported. Things like description, MTU, VLAN tagging. All these things are supported, plus a bunch more. Basically, all the basic stuff is supported right now for a port level configuration. So the deployment step uses Ansible. Ansible uses a filter plugin, which is the driver I was talking about. That's written in Python that takes these manifests. It takes the existing switch configuration. It compares them and decides that, okay, I need to remove these configurations and I need to add these configurations. So it'll actually ensure that the manifest is deployed and nothing else in addition to that is deployed. So it truly ensures that the manifest is the source of truth there for what's running on the switch. So you can see an example of an Ansible task there that calls the filter plugin for that. And on the bottom, you'll see what the output looks like, which is just an example, 4 lines. You see the switch name and the commands it's running on the switch to deploy that configuration. And lastly, we've recently completed development of a continuous deployment solution. Taj at Red Hat completed that work. He's over there. This is a Python application that's containerized. It allows us to listen to the repository where the manifests are stored, and when it detects changes, it'll actually go out and deploy those changes and then report via Slack success failure, any messages associated with that. So this continuous deployment solution isn't deployed at the moment, but we're hoping to get that done pretty soon this year. So that's the kind of last piece of the puzzle to get this to be a full pipeline. So for future work on this, we want to support additional layer 3 configurations. Our network, because of systems like ESI and Cloud Lab primarily using it, are very layer 2 focused. So that's kind of what we designed initially with this is layer 2 configuration. So we don't really have a ton of options for things like BGP and layer 3 ACLs and a bunch of stuff like that that switches do support, but we don't support them in the manifest. So we'd like to add support for that. We also don't have support for system level configuration at the moment. So things like spanning tree bridge priorities, which are tied to the system itself and not a specific port on a switch, and also global like VLT or MLAG configurations that the OS 9 calls MLAG VLT. So stuff like that is also a system level configuration. We'd also like to add additional drivers because the goal for this really is to share it and have other people try it out as well. And we primarily run Dell OS 9, so that's the driver we implemented initially, but we would certainly love to develop a Cisco driver because that's a very common brand and a bunch of others, ideally. We'd also like to publish this to Ansible Galaxy. So our repository at the moment is just our own Ansible site, the filter plugins directly in there. So we'd like to split those up and publish the generic portions of this to Ansible Galaxy so that other people can add it to their environment very easily. And lastly, the only thing that this doesn't solve, this solves a piece of the puzzle, but it doesn't solve everything, is that we want to have the ability to dynamically populate our inventory management solutions. So things like Netbox or anything that's user-facing in the future, we'd like to dynamically populate using these manifests, and that way these manifests in this project are the source of truth for not only the admins but the end users as well when they want to go in and see topology for things. Are there any questions?